my screen pretty well right now. Apologies if any of the code might end up being small. Sometimes GoToMeeting tends to go weird, do weird things, going from like a 27-inch screen to other size screens. So this morning we're going to be talking about the upcoming release for the OWASP GoatDroid project. So we're going to take a look at what's new, what's improved, and we're also going to look at the project roadmap going forward. We're also going to talk about different ways to potentially contribute if you're interested in doing that as well. And so probably don't have to do much of an introduction since Kate did a great job. So we can kind of skip this one. So what's the GoatDroid project all about? So GoatDroid is pays homage to projects such as WebGoat, the original WebGoat, WebGoat.net, all within the same group. So basically GoatDroid aims to help developers, security teams kind of wrap their head around various Android application security issues. And as we talk about the project roadmap, we'll see that GoatDroid's kind of going to expand beyond just supporting Java and the standard Android build environment, and we're actually going to start looking at other frameworks and also integrating other technologies into the platform as well. Certainly wouldn't advise running GoatDroid on any production systems. It's intentionally vulnerable everywhere. We made absolutely no attempt to make it secure, so friendly disclaimers, you probably shouldn't run this on a web-facing box. Everything within GoatDroid is open source. It's all licensed under GPL v3. So you're free to use it, extend it as you want, as long as you give the code back to the community. And by the way, we'll take questions at various stopping points between transitions between sections. So if you have questions, please feel free to ask them, and then we'll just answer them as they get queued up. So right now, GoatDroid is full of bugs. Realistically, probably about 2 weeks out from the 1.0 release. So we're plucking out bugs. Actually did a lot of code revamp. Definitely wrote some spaghetti code a few years ago, so we got a lot of that stuff out of there. Beefing up the documentation. So in the initial releases, one of the weak points of the project was we had a lot of cool bugs. We kind of hoped that people would essentially end up writing the documentation for us through various blog posts and whatnot. So if you would Google for it, you'll see some people have actually found some of the bugs. Definitely haven't seen all of them documented, so we're working towards that now. Additionally, we're also adding a phone gap application. So phone gap application adds quite a different attack surface to what you kind of see in native applications. And we thought it would be a good place to start, just given the fact that phone gap's really popular these days. So if you want to contribute to this, there's actually several ways you can do it. One way is obviously contributing code. So if you're interested in building some additional modules for things that may not be there right now that you'd like to see supported, feel free to go for it. If you're not a developer and you want us to build a few, that's perfectly fine. If you submit feature requests, we'll make sure that they get in there at some point. Reporting bugs is also really important. We'll find a bunch of them, but the rest of you are going to find the rest of them. And last but not least, help spread the word. So developers should know about this. Security teams should know about this tool. Pretty much anybody that has a vested interest in Android security should probably touch this at some point. So let's talk about what else is new in the 1.0 release. So we've definitely beefed up the documentation. In the original release, we kind of gave you clues to where things were, but not necessarily the actual, treasure chest of where they are, treasure map rather. So we've gone ahead and actually thoroughly documented each of those areas. We talked about the phone gap app. Actually abandoned it for those of you that used the earlier release. Happened to stumble upon the Swing GUI. It was actually really painful. It was really ugly and just wasn't fun to extend. So we scrapped that in favor of a web application. So now it should make it a lot easier to contribute and actually add new content as we go. Other important things there, so we're also looking at new lab exercises for the more recent versions of Android, which may potentially change security model around in some ways based on earlier versions. For example, a content provider in newer versions isn't automatically exported, so we've built exercises to kind of touch on those things. If you're supporting older versions of Android versus new, just kind of showing you where the differences are in terms of security issues. And so we support the OWASP top 10 mobile risks within GoatDroid right now. As I always encourage everybody, definitely don't stop at 10. So the top 10 is certainly a great awareness document. It gives developers at least somewhere to start, but it's certainly not what you should build your security program around, and it's certainly not what you should be telling your developers to only focus on. So we actually have things inside of GoatDroid that venture outside of the top 10, and I'd encourage you to do that as well. So getting started and up and running with GoatDroid. So we've approached it in two different ways. Compared to, say, for example, something like WebGoat, which you pretty much go lesson by module by module. We kind of try to give users of GoatDroid two different options. One way you could take the guided route, and the lessons will tell you exactly where to go. And it'll tell you exactly what you're looking for, and if you really need the solutions, which we'd hope that you'd at least try to solve some of the problems yourself, but if you get stuck, the solutions are there to save you. The other option is to simply dive into the applications. Don't bother using the guide and lesson format. And then, once you kind of get to a stopping point, go back and see what you didn't find, which would probably usually be an interesting exercise. So prerequisites for getting started. You really don't need much outside of GoatDroid. So GoatDroid embeds the web server, it embeds the database. All that stuff's there except for the Android SDK, Android ADT, which integrates with Eclipse. And you're going to need Maven as well to build. If you're going to actually build it from your IDE and run it, then you're also going to need Maven as well to pull in the dependencies. So getting started is actually extremely simple. So you basically going to go in the GoatDroid folder, and you simply double-click the GoatDroid.jar file, and it magically opens everything up for you. But today we're going to run it out of Eclipse, just so we can set breakpoints and kind of take a deeper look at where we're going. So let's launch the GoatDroid GUI. So pretty much once you start it, all you're going to do is go to your web browser, and you can see we already have it open. And that's pretty much it. So you're going to go to port 12,000 in your browser, and you'll see, so this looks a little bit different than the Swing GUI that we had before. So you have each one of the applications. You have the two native applications, and then the PhoneGap application, and the associated exercises. So we're still plugging in the content to some of these, but just to kind of give you an idea of what it looks like at this point. So if we were to browse here to, let's look at cross-site scripting, for example. So each exercise is going to have a description now. It's going to have the actual, the bug solution code, and then if you just want a hint but you don't actually want the solution, you'll be able to click here, and it'll give you, little tidbits to hopefully get you a little bit closer to where you want to be. Other things of significance in the front end, configuration. So this is where you're going to set, this is actually going to automatically update in the 1.0 version, where it should attempt to auto-detect your SDK path, and it should auto-detect your virtual devices depending on what OS you're on. The other parts, so the UI web port and then the web service port, there's default values, but if you want to override those, you can do so easily from here in the configuration. And that's pretty much it for the front end. We have a few tools we're migrating from the Swing version to be able to send the location, to be able to send a phone call, and to be able to send SMS messages. These are just simply wrappers for, believe it or not, Telnet. And these were also supported pretty well already in Android's DDMS. You have the option to do these things as well. But we just figure we put them there as just a kind of convenience tool if you're using it in a classroom environment. So yes, getting started is really, really, really easy. So you pretty much just click on that jar file, and everything's there. So if you would happen to look on the class path, you'll see that there's all these things are actually within the jar. So you have a databases folder, and you have the databases under there, and here's all your Spring configuration stuff. So when you actually start that jar, everything is actually built along with it. Any questions so far before we start diving into some of the nitty-gritty stuff? Okay.
No questions. So far, you're doing a great job, Jack.
Okay. So as we mentioned, the web front end before was Java Swing GUI. It was definitely a bad choice. I kind of knew it after I released the initial version. So I was eventually hoping to circle back and migrate everything over to a web app. But we did talk about this a little bit. So just know that the front end is where you basically, if you're going to contribute, you're pretty much just going to plug your content in there and pointers to your application, and then everything should magically work. So right now, in terms of application support, so in the initial versions, we had the 4Goats application and Herd Financial. So 4Goats is a location-based social network. It's a blatant ripoff of Foursquare. And in the 1.0 version, we're working on the PhoneGap version of that. So it leverages the same RESTful web service, except that it's obviously using PhoneGap instead of just native views to build the application, which means you're also building your application in HTML5, CSS, and JavaScript, and that also means that you potentially inherit all the problems of the web within your mobile application. So it's a really interesting way to see how both of those worlds are kind of blended together. But the good news is that we've already written the web services for you, so if you want to contribute to this project, you don't really have to focus much on server-side development. You could just write in an application that consumes the web service, or you could write code that doesn't consume any web service and just shows examples of poor programmatic practices on an Android application. So it made it a lot easier going forward to contribute, which was definitely one of the roadblocks in the first couple versions of the app. So let's take a look at some demos. We'll give you an example of some of the vulnerabilities that are there, but we definitely hope that you would dig in a little bit deeper and find a lot of this stuff yourselves. So the first one, we'll take a look at insecure data storage. So we're actually going to fire up the 4Goats application here. Actually, open this one up. So, by the way, for those of you that are using the Android emulator to do your testing and development, definitely recommend Genymotion. It's definitely a lot faster, and it'll save you a lot of the headaches of using the standard Android emulator. If speed is your thing, of course. So let's go ahead and relaunch that under here. Okay, so you can see same pretty UI. I actually didn't build the UI to this. Another gentleman named Walter did. So he actually approached me, looked at the UI in the original version. So it was pretty much just taking data and stuff it into list views. And I guess he felt a little bit of pity for me, and he said, "Hey man, I'll go ahead and basically revamp it, build in the action bar and all the pretty stuff." So any of the prettiness that you see within these applications, please don't attribute any of that to me, because other people did a good job building that out. So, I'm sorry, did I hear something?
No.
Okay. So the first thing you're going to do when you get inside of the application, I've actually gotten a ton of issues submitted about this. It was actually there in the Getting Started guide. So the first thing you're going to want to do is go in and set the destination info. So basically what this is doing is setting the remote server where it's at. Because if you were to set this to the loopback, then it's actually going to point right at the Android emulator instance itself. So you actually want to point at the IP address of whatever particular host where the web server is actually listening. So in this case, it's 1.3, and we're actually going to use port 10,000. Additionally, so for the proxy host and the proxy port, so when you're testing an Android application, you generally have a couple different ways to get the application to actually go through your proxy. So one way is to actually build it into the HTTP client classes, which we did for the purpose of this application. So you can look in our REST client, for example. There's just a simple hook here into the HTTP client where we set the proxy, and then whenever HTTP requests are made, it automatically goes through our web proxy. So that's one way to do it. The other way to do it is there's several applications if you're working on a rooted device. One of them I'd recommend is ProxyDroid. Really handy. Just sets basically some IP tables rules and allows you to push your stuff through a proxy. But to make this really easy in a classroom environment, we just built the proxy capabilities right in. So people didn't have to spend a ton of time getting up and running on that. So that's pretty much it in terms of getting started. We set the IP address, we set the port. If you want to use a proxy, which you're probably going to want to, you set the port of the proxy and done. Okay, let me just kill this service real quick. I think it's coming up. All right, and now we can go ahead and start that again. Okay, so now we should be listening. So when you start the jar, it automatically also starts a listener on port 10,000, which is where the web services are. And then port, again, 12,000 is for the front-end UI. So we have default username, password of both GoatDroid. Okay, so we've set our destination info, and now all we have to do is hit the login button, and should be hitting the web service. Okay, so you'll see immediately when you log into the application, you have two things. You have the Remember Me functionality, and then once you log in, you get all this information back, including your authentication token that you're going to use for subsequent requests to the API. So as you can see, we have a couple different things here, check-ins, friends, rewards. If you would actually dig into the code, you'd also see that there's some admin functionality, and there may be some different ways you potentially elevate to administrator, but I'll leave that to you guys to figure out on your own. But one thing in particular we noticed, so we had that Remember Me functionality. So let's actually grab a shell on the Android device, and we're going to take a look at what that Remember Me functionality is actually doing. So we're going to do ADB shell, which gives us a shell on the device. So now we can actually manage all right, so now we're inside the actual application's data directory. So each application on Android within the CD data app directory, you'll find the actual APKs themselves, which is just an Android package. Within the data directory, you actually find the actual data used by the application. So if we take a look here at the Share Preferences folder, and we just gonna. So we have a few different XML files here. So if we take a look at the user info.xml file, what do we notice here? So we have the user's password in plain text, which is never a good thing, and we have remember me set to true. And if we go back and look at the actual code to do that, if I can find it. There we go. So you'll notice that at that remember me box is checked. There's another check down here, so we'll hit, log in, check credentials. That fires off an asynchronous task, which sends an HTTP request to the web service. And we can see down here, if remember me is enabled, then we run save credentials. And if we look at save credentials, you can probably imagine what's happening. We're just simply persisting the file to, we're just simply persisting that information to a shared preferences XML file. So you can actually see a couple problems. One, we're storing the password in plain text, which you should always try to avoid that at any cost. There's generally a better way to do it than actually storing actual credentials. You might want to just basically store a token or something else that's not, going to actually, if someone gets access to that application and that data store, isn't going to actually get them access to other applications potentially. At the very least, you want to limit the bleeding to your application. The other problem with it is that we also have this file as mode world readable. So the significance of this is that other applications, for example, malicious applications, can actually also read that file as well, which is bad. So there's obviously ways for other applications to get to that. In the event of a lost or stolen or compromised device, then that data also becomes accessible as well. There are some potentially edge cases where other applications, or even that application can actually fetch that information remotely. You might see that increase a lot, like for example, like in a phone gap application, where you have the ability to potentially call arbitrary methods using JavaScript. So you can actually do some pretty interesting stuff. That also extends the potential reach of some of these vulnerabilities as well. Let's take a look at another one. There's definitely a lot more bugs in here than I can ever get through in an hour. So again, I definitely encourage you to go back and take a look at it on your own. The next one is insufficient transport layer protection. So if you noticed, so we were able to run this through burp just fine. The problem with that is, for those of you that are kind of a little bit more advanced here, you'll come to the quickest realization that the application completely ignored any certificate warnings. For example, the host name doesn't match, the CA isn't within the trusted chain. So a bunch of basically certificate errors were just gobbled up by the application and just silently basically ignored. And there's a reason for that actually. So if we go and look at the main activity, so this is the first thing that gets fired off when the application starts. And you can see that within the onCreate method. So the onCreate method, as soon as an activity is invoked, the first thing it does in its life cycle is calls the onCreate method, or close to the top, right? And you can notice the first thing that happens is we call this one particular method right here, SSL certificate validation .disable. So if we go down here and we take a look at that disable method, you'll notice that within our trust manager here, we're just basically not doing anything. We're returning true. Various different things happen. So we're not actually doing anything to prevent a man-in-the-middle attack here, and we're not doing anything at all to actually alert a user that it's actually happening. So we call this method statically, and this basically, we call this before any other HTTP requests are made, and the significance of that is that any subsequent requests are just simply going to inherit that setting where it just sets everything off. So that's one potential place you might see that happen. In the old code we had, for example, down here, we created it with a custom SSL socket factory. And so you might see something like that as well. So you may see it when you find this particular bug. You might see it set centrally somewhere that's outside of your HTTP client class. or then you might see, in this example, like where we just basically passed that factory in there, and you can see down here, we're essentially doing that same behavior, except we're just doing it, a little bit differently. But same problem, different places to find it. So the obvious solution to this one is just, unless you're pinning your certificate and explicitly declaring which certificates are valid, you generally don't want to ever turn this off. There's usually no compelling business reason other than the fact that you have a self-signed certificate and you didn't want to get one by a real CA, basically. But generally, 9 times out of 10, there's no legitimate reason for anyone to do this in a production application. All right. We'll take a look at client-side injection. So this stuff actually happens quite a bit. So XSS is actually, unfortunately, so we're grouping pretty much anything, XSS, SQL injection. We're just kind of lumping them all under client-side injection. SQL injection, not quite as dangerous as like a server-side, but at the same time, there's certainly still some dangers of SQL injection on Android. But XSS is actually, and when we start talking about, or we start looking at like a phone gap application that's built on JavaScript, HTML5, and CSS, the prevalence and impact of these vulnerabilities are definitely elevated a little bit when your main way to access native functionality is through JavaScript. So we'll take a look at an example of actually both here. So if we look at the view profile here, actually, I'm going to look at view check-in activity. So you can see this probably is the worst way you could ever generate HTML. So basically what we're doing is we're passing in things from a bundle, but which these things are, so for example, the venue name and all these other things that are set within the bundle, those things are actually pulled from untrusted data. So it's retrieved from the REST API. So it's basically untrusted JSON data stuffed into a bundle and then from there concatenated into HTML that's passed into an Android web view. So kind of touching on a web view really quick, if we were to look at the resource file for this, which is just simply an XML file with layout information. So basically a web view, all it is essentially embedding a mini browser type of thing into your application. So it uses WebKit and you have access to the full DOM. There's some obviously same origin type restrictions in place. There's some I guess interesting rules that let you bend that to an extent. But for the most part, what you'd expect in a browser application is still there. So in this particular problem here, so we have a couple things. So for starters, we've enabled a JavaScript interface. So this mechanism allows you to basically call native methods using JavaScript. So you can imagine the potential power, but at the same time the potential danger of doing this. So in this example here, we are allowing the person to do calls to a JavaScript interface that also allows you to send SMS. So as you've probably figured out, triggering this XSS will actually allow you, and actually let you do it remotely at that, when someone actually opens up the content, which this is actually within check-ins and comments. So it's one of those things it is the high likelihood that you're going to get hit with the stored XSS. And as soon as that person fires it off, it's going to shoot an SMS message off on their behalf without any user interaction. Within newer versions of Android, there's actually something really nice. Within these JavaScript interface classes, you can actually set an annotation on a specific method that'll tell you that, hey, this method is allowed for JavaScript. So basically what happens is like developers will expose an entire class. They may make all their methods public, and they only intended for the JavaScript to actually call, say, one or two different methods within that class. So in more recent versions of Android, by default, unless you actually tag it with the JavaScript interface annotation, then it won't actually be available within the JavaScript interface, which is a good thing. It's a good default to do. Talking about capability leaks, so just kind of give you a quick overview of the Android permission system. So you have, in Android, you have application level permissions. So basically, if you declare send SMS, then the application can actually call different APIs that interact with, let you send SMS. If you don't have it, then Android, when you try to actually call that at runtime, Android will throw a security exception. So you actually, in order to use these things, you actually need to declare these different permissions. So some applications actually allow lesser privileged applications to potentially pivot and increase their permission level because they'll expose a different component that doesn't necessarily require the same permission that it actually allows you to use. So as an example here, we can take a look at the send SMS receiver, send SMS now receiver. So if we take a look at this broadcast receiver here, we take a look at what happens. So when a broadcast is received, it just simply grabs that. It grabs the information, including the phone number and the message, and it just sends off an SMS message. So there's actually a few problems with this. So within here, you can clearly see that this allows you to send SMS. So you need the SMS permission to do it, and if you have the permission, you can send the message. But the problem with this is that anyone that can actually call that broadcast receiver, so an application that actually has 0 permissions can send a broadcast to this application and tell this application, on behalf of me, send out an SMS message, even though you don't have the SMS permission, which is a problem. So the only thing that's actually required here is that you would use this particular action. So actions don't require any permissions. Actions are part of the intent resolution process, which really Android uses that to determine which is the best component to receive an intent. It doesn't really use that to restrict it from a security perspective, because even though a specific action can be in place, you may and it doesn't prevent you from explicitly invoking that, even if you don't hit it within the Android intent resolution process. There's only a few ways you can do that. The biggest one, obviously, is setting permissions. So if you would want someone to hold a specific permission, then you would simply pass in some.permission to require, for example. And when you would actually try to invoke that component, if you didn't have the specific permission required, then Android would throw an exception that wouldn't allow you to actually leverage that. So this is something really commonly encountered where you'll go from one privilege level to another, just simply because the developers forgot to require permissions to happen. And by the way, you can also require permissions at the application level. So each of the components in Android inherits from application. So each of these elements is always found under application. So you can also, at the application level, require permission. And this is actually going to propagate down to all the other components declared in the application. You could also set, for example, some permission here. And then down here, you could actually set a different permission if you want to. So at the very least, you can set an application-wide permission. You need at least this to basically get in the door. But then you could, of course, override that if you, say require a different permission or you want to be more granular for some reason. Some other permission here. And so what ends up happening is that if you declare a permission at the application level and at the component level, the one that's declared at the component level is going to take precedence over the one at the application level. So at the very least, depending on the kind of application you're exposing to other applications, you may want to consider setting it application-wide just as an initial security boundary, and then basically get more specific where you need to. It would actually save a lot of developers a lot of pain. Another thing also, a lot of developers don't realize, so there's two different ways to expose one of your Android components. The first way is to explicitly do it, and we've actually done that here. So what we've done is Android exported equals true, so when you actually set this attribute, it's going to say that other applications can invoke that specific component in your application. And then, of course, after that, it goes down to the permissions and all that stuff. So that's one way to expose it, is by explicitly doing it. The other way to explicitly expose a component is by setting any intent filters. So again, an intent filter is there just basically to help Android figure out where it should be sending certain things. But as soon as you expose an intent filter within a component, it's automatically exported at that point. So you have a couple options at that point. Set exported equals false, and just make sure that it can't be exported, or be granular to permissions and checking who's calling it and so on and so forth. This actually represents, by the way, a significant portion. We talk about components and IPC on Android. It represents a significant portion of the Android attack surface. So if you're just getting started out with Android, for example, I definitely recommend that you spend a lot of time getting familiar with the various components. So you have activities, broadcast receivers, content providers, and services. So each of them actually has a slightly different life cycle, and the life cycle plays a huge role in the security of a lot of those things as well. For example, there's certain things that you wouldn't want to do in like the activity on destroy, which would be like clearing out sensitive files, stuff like that, because you're not actually guaranteed for that part of the life cycle to be called. So if Android, if your device, if you just pull the battery out, it doesn't happen. If the application crashes, it might not happen, so on and so forth. So there's certain things dependent upon the life cycle that you should or shouldn't do in there. So a good place to start is really learning the ins and outs of the Android components. Let's see, so we talked about capability leaks. The last bug we'll kind of hit at a high level, sensitive information disclosure. So another thing developers like to do in Android applications and mobile applications in general is hard code various values within the actual binary itself. So in this example here, so this is the login activity. So this is what we saw before where we punched in our username and password. Is the initial login activity. And what you'll notice is if you actually dig down a little bit into, so from here, we've sent our credentials off, and then we handle the results of that in an on-post-execute method. And what you'll notice here that if we had a success, we want to check down here so that we could either fire off the home activity, is what you saw here, for example. And then there's also an admin home activity, which would actually have an additional icon there to give you access to admin functionality. So what you'll notice is that there's actually two ways you can actually invoke the admins. Excuse me. One is that if that initial request and response when you logged in, so if your isAdmin was set to true, then it's going to look for that in your shared preferences, which you should be able to see over here, isAdmin equals false. So that's the first place it looks. And then the second place it looks is if you have a username of customer service and a password of account management, then it automatically puts you into that as well. So the problem with this is the fact that this is actually going to be available to anybody that would actually download your application and attempt to reverse engineer it. So there's a ton of different tools out there that make it really, really easy to do this. Essentially what you're doing is going from Dalvik bytecode back to either human readable Java form, so you can use Dexter jar as one tool that allows that. You could use Smalley, box Smalley. It converts it to a Smalley format, which just basically makes the Dalvik bytecode readable. So that's another potential way you'd be able to get to this. So you can try to obfuscate all day, but I guarantee you that it's, obfuscation is going to end up being more of a kind of a speed bump as opposed to a roadblock. So if you're doing this kind of stuff, I would definitely recommend not doing that, because there's a fairly good chance that this kind of stuff is going to be recoverable by a bad guy. So there's a lot of other, I know we kind of hit some of the high-level bones here, but there's some other ones in there ranging from really simple to really complex. So for example, you may have to jump through an issue with a component being exposed to others, but you may actually have to use that to potentially jump into another component that may be hidden or only available internal to the application. So you may have to use that as a hopping point, pivot, and then potentially carry another type of attack. So we've done a decent job at kind of showing how some of these things can be chained, where one vulnerability potentially opens up 4 or 5 different other vulns. So there's a lot of issues within code. There's some issues within the configurations, especially in the phone gap application. So phone gap does a lot of nice things for you when you create an application out of the box. So for starters, it enables all these permissions for you. And PhoneGap is, so it kind of works a little bit different than a native application. So when you actually start it, for example, so in your initial activity, you'll extend droid gap, and then you basically load the start URL, which is set within a configuration file. The configuration files are under resources, config, and under resources config you can see, and this is actually like out of the box, aside from adding a few different plugins, like it's for the most part exactly how PhoneGap creates an application for you. So a couple things you'll notice if you're looking at one, these are all, aside from these things, these are all the default plugins that are automatically enabled for you, including the permissions, which includes geolocation, contacts, files, storage. These things let you get access to SQLite databases, to share preferences, to the contact list. So some really powerful capabilities are exposed via JavaScript, CSS, HTML5. So when you look at XSS, it's not as prevalent, I'd say. I go out on a limb and say it's not as prevalent in native applications, although it's there. It's definitely there. But when you look at PhoneGap applications, I mean, this stuff is basically everywhere. So the out-of-the-box configuration potentially exposes all these different plugins to an attacker. And I guess the kind of the cherry on top of that is PhoneGap is also given, taking the luxury of setting this as a wildcard for you. So basically what this says is that any domain is able to load JavaScript and execute it within the context of that application. So in a standard, say browser type of application, you have some same origin model, separation. So if you try to grab cookies, for example, of another domain and you load it from somewhere else, then it might not allow that. But if you're storing that in, say, a shared preferences file and you're loading JavaScript from a third-party domain, and that, says, hey, call this shared preferences file and read out whatever's in it and post it back, well, that's probably a lot more likely because, one, you wildcarded it, and two, you have both the permissions and the plugins available to do it as well. So the benefit of adding the PhoneGap application is to kind of give you a different perspective of, basically native versus, mobile web applications, essentially. So now we'll just take a look at slides for a few minutes. So the project roadmap right now, let's talk about that. So here's kind of where we're at. We definitely have a lot more in terms of the lessons we want to provide, but we're probably closer to that than we were before. So the next, not going to probably be there in the 1.0 release, but hopefully not too long afterwards. We want to start distributing GoatDroid as part of a virtual machine or a virtual machine that sets up the GoatDroid environment. So we took a look at, for example, using, the idea of using the Broken Web Apps project. And what we found is that basically Broken Web Apps does a great job at giving you a bunch of different vulnerable applications. But if you want to use it, say, for example, to have your IDE, SDK stuff, basically all already set up in there and ready to go, Broken Web Apps doesn't really give you the capability to do that. So combined with things that we want to add to the application, such as, which I'll talk about, NFC support, it just made sense to basically start working on a distribution. And it's also going to make it a lot easier for us to push updates out along the way as well. But the benefit of obviously having a fully configured environment is that if you're using it in a classroom environment, people that are newer to Android, there's a little bit less of a learning curve in terms of getting everything set up. So you could actually spend less time on configuration and more time on actually learning new concepts. We also want to expand beyond just Java, Android, and PhoneGap. PhoneGap right now, by the way, is using jQuery Mobile. We'd also like to support other JavaScript frameworks, other JavaScript UI stuff. Additionally, so people aren't just writing, surprise, surprise, their applications in Java and JavaScript. They're also using .NET in the Xamarin project. There's actually people writing Ruby applications with Robuto. And believe it or not, in our travels, we've actually seen some people starting to use Scala to write their applications as well. So over time, we hope to have enough code examples in enough different languages and frameworks for developers of all shapes and flavors to be able to look at the applications and learn about what's actually relevant to the development environment they're working in. Beyond that, so we want to start using NFC, OpenNFC for Android. So as opposed to having a couple different NFC enabled devices talking to each other, to do it in a lab environment, we want to alleviate you from actually having to be able to do the wireless communications on real devices. So the best way to do it is, in our opinion, is using OpenNFC to do it. So within the next few versions, so after we get the initial VM off the ground, we should have that capability. And in the next, couple of iterations of GoatDroid, we're going to start building out NFC exercises. So if there's any of you on the webinar today that are really, really strong with NFC, we definitely love to have somebody, help kick in some cycles to build some of these exercises out. So as we kind of wind down here, definitely want to thank everyone that's helped to date. We've had a few code contributors. We had a bunch of people that have contributed in terms of feature requests, in terms of reporting bugs, recommendations for how to make it better. It's definitely a community project. It's so, again, it's open source. It's out there to be used as you want. But yeah, it's certainly not going to go forward without people helping out. So thanks to everybody that's already helped. And thank you to those of you that are actually going to help going forward. So that takes us to the end of the presentation. So if you want to grab the code, so the current master branch is full of bugs. They'll run, but definitely plucking bugs out. So you've been warned about that. But it should be pretty stable pretty soon. For more information about the mobile project, I've also posted a link there for that. All the tools are there, and then we also have the top 10 list. We have some stuff on security testing methodologies. We're actually going through a revamp of the top 10 now. We should be posting that stuff up there pretty soon. So I'd say keep your eye on the mobile security project on the wiki. And last but not least, if any of you guys want to follow up with me, whether it's questions about the existing code base, if you want to get involved in being a contributor going forward, I mean, I'm happy to give anyone basically push-pull access to the repository. If you're serious about it and committed to committing code on a regular basis, I'm happy to give anybody access that wants to add something to it. So with that said, that takes us to the end here. So if anybody has any questions, I'd be happy to take all of them now.
Thanks, Jack. You did a fabulous job. And it kind of ran us right into time, so that's great. And I don't see any questions from the audience. That doesn't mean that they're not there. To those who are listening, if you need confirmation of attendance for your CPE credits, you can send an email to support@OWASP.org, and I'll be happy to send that out to you. I also put Jack's email in the chat window, and if you found today's webinar helpful, it will be posted online, and it's also going to be shown again tonight at 9 o'clock Eastern Time. So if there are colleagues, coworkers that you think would benefit from listening to what Jack has to say, please encourage them to sign up for this afternoon's or for this evening's webinar. So one last chance for questions. Did a great job, Jack. I'm sure you'll get inundated afterwards. All right, well, thank you for joining, and keep your eyes peeled on the connector for future webinar topics. Thanks. Have a great day.